Hello class, welcome to Algebra Concepts Lesson 1-4, which is all about the distributive property. By the end of this lesson, you should be able to simplify expressions by using the distributive property. So we're going to start with some mental math using the distributive property. Okay, so what we're going to look at is we're going to start with 5. And then instead of saying 5 times 99, because that's not just like a quick off the top of the head, you know what that is. What we're going to do instead of doing 99, that's really close to the number 100. So in order to get to 99 from 100, I would say 100 minus 1. Okay, so I'm substituting 100 minus 1 in here instead of the number 99. And the reason that makes it a little easier is because now it's really easy to say, what's 5 times 100? You're probably able to answer that pretty quickly and say 500. Then I say minus, and then 5 times 1, you probably can rattle that off pretty quickly too, and say 5. Then if you do 500 minus 5, you probably know that that's 495, and that's your final answer. Okay? So if you rewrite a number like this, it can go faster for doing some mental math. So like for here, instead of writing 1002, I'm going to write 1000 plus 2. Because 4 times 1,000 is 4,000. And then 4 times 2 is 8. So I know my answer would be 4,008. And I'm all done. Okay, so I want you to practice some of these problems using mental math like that and showing your work. If you don't show your work on the test for this one, I am going to take off some points because I want you to show me that you know this process, okay? So it's very important that you practice showing your work here for this, any problem that says mental math, okay? All right, moving on, let's practice distributing an algebraic expression from the left. So this is the most common way that you'll see things written for the distributive property. We tend to like to have numbers outside of parentheses on the left-hand side. So in this case, it's a 4. So the distributive property is where you distribute, you multiply everything inside the parentheses by whatever's outside. We worked with this a little bit last year, and we're going to continue working with it. So 4 times 5 is 20, and then there's also an x with that. So I leave the x just tagged on to that number 20. And then I have minus 4 times 7 is 28. And this is my final answer. And this is my final answer because one of those terms, the 20, has an x and the other one does not. If they both had x's, I could combine them, or if neither of them had an x, I could combine them. But since one number has an x and the other does not, this is my final answer, okay? It's really tempting just to put those together and say negative 8x, but that is not correct. That is not what you should do because those don't have the same term. They're not like terms, right? I want you to do this one on your own. Rewrite using the distributive property, then simplify. Okay, so negative 6 times the quantity of r plus 3g minus t. So you have letter A, B, C, or D. Go ahead and figure out which one is the correct answer. Good luck. Okay, for this problem, hopefully you said negative 6 times r is negative 6r. Negative 6 times 3g is negative 18g. And negative 6 times a negative t is positive 6t. So that would be letter A. All right, example 3. We're doing the same thing, but this time we're distributing from the right. So I'm going to take that 6 and I'm going to multiply it all the way over here. So 6 times 3 is 18y to the second. And then I'm just going to change colors to help make it maybe a little bit easier on you. So then I'm going to do 6 times my middle term, which is a positive y. So I say plus 6y. And then my very last one that I'll do is I'll say 6 times a negative 8. So positive times negative is negative, and then 6 times 8 is 48. So my answer would be 18y squared plus 6y minus 48. Okay. If you have questions about that, please ask for some help. I am so happy to help you. I don't want you to sit there confused and miserable. So please ask for some help. All right, so now we're going to talk a little bit about combining like terms, and I know this probably looks really silly because there are a bunch of chickens and cows on your screen, and the reason I like to do this is it sometimes makes it a little easier to talk about combining like terms. So if I were to ask you to describe what is on the screen, you would probably say, you would probably say there are 1, 2, 3, 4 cows. So you would say, okay, there are 4 cows, Miss Johnson. You wouldn't just say cow, 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 chicken, 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 chicken. That gets to be obnoxious. You would say there are 4 cows and there are 1, 2, 3, 4, 5, 6 chickens. So 4 cows, 6 chickens. That is probably what you would tell me if I asked you to write what was on the screen. You'd say 4 cows, 6 chickens. Okay? And then I'm going to ask you, why didn't you just say 10 chickens? Or not 10 chickens, sorry, 10 animals. And the reason we don't do that is because we can be more specific, right? Those 2 animals are not the same. They're both animals, yes, but they are different. So we group them differently. Okay, we'd say 4 cows, 6 chickens. We would not group those together. Just like here, I have an A term and an A term. This is like 14 chickens plus 18 chickens. Okay, if I had 14 chickens and then 18 more chickens, that would be 32 chickens. And by chickens, I mean we are not talking about chickens. We are actually talking about the letter A. So I would write 32A. Okay, and then over here on the right, I have 4b squared plus 9b minus 3b. This b squared, that's like cows. B, we're going to say it's chickens. They're 2 different things, right? They don't match perfectly. So this 4b squared cannot be combined with the chickens. I leave them separate. I say 9b minus 3b, 6b. Those 2 variables, while close and similar, are different. So we do not put them together. So my combining like terms would tell me I have 4b squared plus 6b. Without fail, every year, if I were to give this problem to students, they would tell me 10b to the third or 10b. And neither of those answers are right. So I hope that's not you. But if it is, that is a common mistake, and that's something that we can fix. Okay? Now, I want you to look at this problem. We have b squared plus 13b plus 13. And I want you to tell me, does it become 13b squared plus 13b? Is it 26b squared b? Is it 26b to the third? Or is it simplified already? Why don't you go ahead and take a minute and think about that. Good luck. Hopefully you realize this one's a b squared, so it can't match with either of the other 2. And then this has a b and this does not. Even though they're the same number 13, they're different because this one has a b and this one does not. So I can't combine any of those, and that is a time where we would say this is simplified. All right, now we are going to write and simplify these expressions. So this is the same idea with the distributive property, but now we're adding in a step of combining like terms. So I'm going to say 3 times 2x is 6x. 3 times 3y is 9y. And then here, careful, we have -2. If there's a negative in front of the sign outside of the parentheses, you include it when you're multiplying. So -2 times 4 is -8x. And then -2 times a -y becomes +2y. Now I look at these and I say, okay, do I have any like terms that I can combine? I have an x term here and an x term here. So I have 6x minus 8x, that's -2x. And then I have a 9y plus 2y, so I would say plus 11y. And I am all done with that problem. Okay, so I distributed and then I combined like terms. All right, if you have any questions at all, please be sure to reach out for some help. I am more than happy to help you. I hope you guys have a great day.